Hey Chem Kids, Mr. C here, and today we're going to talk about density and how to calculate density and what exactly is density in chemistry. So in chemistry, density is simply the mass per unit volume, and we're always going to express that with either the units grams per centimeter cubed, or we might do grams per milliliter. So it's kind of important to know what units you're dealing with, because if your units aren't in grams or they aren't in centimeters cubed, or milliliters, you might have to do a unit conversion first in order to get those into the right unit. So every substance in chemistry has a density to it. And basically density kind of tells you whether things float, or if they're going to sink, or if they're going to go really high up in the air, if they're just going to stay where they are. And actually density is like whenever you go to like a souvenir store and you see all those cool little things and they're filled with all the different liquids, and each level has a different color liquid in it. They're all different, they're all floating, and you shake them up and they get all mixed up and jumbled up with each other, but then eventually they go back to where they used to be. Well, that's because of their density. And basically, the lower your density is, the higher up in that tube you're going to be. Light things like to float. So the lighter you are, the lower the density you are, the higher you're going to float up. That's why, in this case, so we have the density of air is 0.013 grams per centimeter cubed, and the density of helium is 0.000166 grams per centimeter cubed. And this kind of explains why a helium balloon will float in air, because helium has a lower density. It also explains why whenever we throw a rock into the ocean or into a pool, it sinks to the bottom, because a rock has a much higher density than water does. Pretty cool, right? Well, now we're going to talk about more about how to calculate density, because that's really sort of the important part of our class here. So how do we calculate density? Well, we know that the formula for density is equal to mass divided by volume. And there's a couple of different ways. One way that we can do this is we can solve for density, or if we wanted to solve for mass or volume, we could actually manipulate this equation. We could say, well, let's say we wanted to find out what the mass is. Well, in order to do that, we have to get mass by itself, which means we'd have to multiply both sides by our volume. So we would have mass equal to density times volume. Or if we wanted to find volume, we'd first have to multiply both sides by volume, then divide by our density. We could get volume is equal to mass divided by density. But sometimes I get it, we don't want to do math. So another way we can do this is we can use our little math triangle here. And the way that you use this is you cover up whatever variable you're trying to find. So let's say, for example, I want to find density. Well, I would cover up density, and whatever's left, I would do that. And because mass is on top of volume, in order to find density, I have to do mass divided by volume. Now let's say I want to go, and instead I want to find out what the mass is. Well, what do? All I have to do is cover up the mass. And I see, well, density and volume are next to each other, so in order to get the mass, all I have to do is take density times volume. Pretty cool. And then finally, just to walk you through all three of them, let's say I wanted to find out what the volume of something is. All I would have to do is cover up volume, and whatever's left, so I find volume. So in this case, in order to find volume, because mass is on top of density, I would take mass divided by density. Pretty cool trick. Let's look at question number 1. An object has a mass of 3.4 grams and a volume of 8.2 centimeters cubed. Its density would be what? Well, we're looking for density. So in this case, we know that density is equal to mass divided by volume, which is going to be 3.4 grams divided by 8.2 centimeters cubed. If we plug that into our handy dandy calculators, which if you don't have out right now, I would suggest you get out, because we'll be using them all day today whenever we calculate density, unless you wanted to do these calculations by hand, which you could if you wanted to, but that doesn't sound very fun. Well, we get an answer of 0.41 grams per centimeter cubed. Always make sure you have your units on there. Units are always very important. And notice that I rounded this to 2 significant figures, because whenever we do multiplication and division, we pick whichever one has the least number of significant figures, which in this case they're both 2. And that's how many significant figures our answer is going to have. So question number 2, what is the mass of an 11 centimeter cubed gold ring if the density of the gold ring is 19.3 centimeters? Well, in this case, let's go up and let's look at our little math triangle here, and we see if we want mass, right? So we cover up the M, and we see that the D and V are next to each other, which means we're going to multiply our density times our volume in order to get our mass. So in this case, we would take 11 centimeters cubed times 19.3 grams per cubic centimeter. And we find out that we have a mass that is equal to 212.3 grams. Holy cow, that is a lot of gold. I like that though. I would be pretty excited if someone gave me 212 grams of gold. So now, what is the volume of helium in a 5-gram balloon? The density of helium is 1.79 times 10 to the minus 4 grams per centimeter. Well, in this case, we cover up volume because we want to find volume. And we see that whenever we cover up volume, mass is on top and density is on bottom, which means in order to find our volume, we have to take mass divided by density. So the volume will be equal to mass divided by density, which is going to be equal to 5.0 grams, all divided by 1.79 times 10 to the minus 4 grams per centimeter cubed. If we go ahead and do out the math there, we end up getting a volume of 28,000 cubic centimeters. That's a lot of cubic centimeters of helium. And finally, our last question, what is the mass of gasoline in kilograms if a tank contains 9.5 liters of gas? The density of gas is 0.68 grams per milliliter. Well, this is one of those times where you have to be very careful about units. So if you look down here, it's grams per milliliter. But our volume's not in milliliters. We have to convert liters into milliliters. And in order to do that, all we have to do is multiply by 1,000. So in this case, our volume is going to be 9.5 liters multiplied by 1,000 because we have 1,000 milliliters in a liter. And we would get 9,500 milliliters. Now we can get on with the problem. We want to know what the mass is. Well, if we go up to our math triangle and we cover up the M, we see that the D and V are right next to each other, which means in order to get mass, we have to take our density times our volume. So mass is going to be equal to density times volume, which in this case will be 95,000 or 9,500 milliliters times 0.68. And that's going to give us a mass of, of 6,500 grams. But we want our answer in kilograms. And in order to get grams into kilograms, we have to divide by 1,000. So our final answer is going to be 6,500 divided by 1,000, which is going to be equal to 6.5 kilograms. Now that we have this all finished, I want you to go ahead and click on that next button down in the corner of your Canvas screen and you're going to click on the link that'll take you to a Google form and have you do some practicing of calculating density on your own. If you ever need any help, please email me or call me in your Zoom breakout room, and I will be more than happy to help out.